Okay, so in this part of our lesson, we're going to talk about how we use the z distribution table or the standard normal distribution to determine probability of a value falling to the left of our z-score. This is a table within our probability tables and stats and stuff, which many of you may not have those at home with you, but it is readily available online, as well as I have a link to it on the Google Classroom. But in case you're wondering, this is table number 5 in our books. So we are going to look at finding the probability of z being less than negative 2.47. If we notice across the left side here, we have our z's. So there's one page that has negatives and one page that has positives. And the areas are, and the probabilities and areas are always left. So negative 2.57, that means I would look for the negative 2.5 here. But to get the 7, I go across the top to find the 7. So what I'm going to do is I'm going to look for where these two things overlap. I'm not going to be able to draw a very straight line here, but we're going to try. So we can see that overlaps at this location right here, which is 0, 0, 5, 1. So the probability that z is less than or equal to that would be 0, 0, 5, 1 or 0.51%. And I don't care which way you write it, you can write it either way. So likewise, if I had, notice that's negative, so make sure you're on the negative side. Here I have a positive 0.93. So I'm going to look for negative or positive 0.9, which is this row right here. And then to get this hundredth, this 3, I come up here to the 3 on the top. It's this column. So once again, it's right here. It's this 8238. So that probability is 8238 or 82.38%. And those are those probabilities. Now, like I said, it only does less thans. So what happens if I have a greater than? Well, that would be areas to the right. So I would look up the table for z, and remember that whole area is 1. So I would subtract it from 1. Or if you really wanted to, you could look up the opposite one. If it's in between, you look up both the z-scores and you subtract them. So let me kind of show you what I mean. Here's a picture view of that as well. And another picture view. So here we go. Use the area of a standard normal distribution table. So this is our z-table. Find the area between 1 and 2.7. So what this is asking us in text to do is what's the probability that z is in between 1 and 2.7. So what I would do is I'd look up the probability of 2.7 and I'd subtract out the probability of 1. Because remember, they both do to the left. So if I'm looking for in between, I'm going to do the furthest to the right minus the furthest to the left. So if I take off this little edge, which would be like right here, that gives us this area right here, which is what we're looking for. So back to this one. So 2.7, and I would look in that table again. So hold on while I find my table here. So 2.7, so that'd be like 2.70. So that's going to be 0.9965. And then the probability of 1 would be like 1.00, would be 0.8413. And then you would end up just subtracting those things. 8413. And you would end up with a probability of 0.1552 or 15.52%. And it does not matter to me which way you go about writing that. And likewise, area to the right. So an area to the right is saying, okay, I want z to be greater than 0.94. Well, recall our table only does less thans. So what I could do is say, all right, area to the right, so that's this one right here. So I could do 1 minus the area to the left. So if I do that, I could do 1 minus the probability of 0.94, which would be 1 minus, and then look at 0.94, which would be 0.8264. Equals. So 1 minus that would be 0.8264, which would equal 0.1736.